and root. Standard, x dash, y dash equals, okay. When we do translations, we do the plus stuff at the back. When we do reflections or dilations, we have to stick the box in front of x and y, okay? So I draw myself a box, and then I put my x, y down. So, dilations is multiplying. True? Multiply the y value, multiply the x value. Reflections is also multiplying, times by -1. So multiplying, this is how you multiply matrices. You put two boxes next to each other. I've got to put the right numbers in here. So, dilation factor 2 from the y-axis. From the y-axis means you are playing with the x values. True? From the y, play with x. That's how you think. Play with x, top corner. Literal. It says 2, I write 2. Don't start thinking about, oh, he flips and all that crap. This is matrices. This is literal. That guy plays with x, that guy plays with y. As in, on the one line. Forget that. That's always 0, that's always 0 for the moment. Okay? It says I ran away from the x-axis by factor 3. Factor 3 is changing the y values. Y values is the bottom corner. 3. Cool? So I've actually, see those two? I put the two boxes together. There's the guys playing with the y, there's the ones playing with the x. You put them in the same matrix. Done. That's your matrix. Set up. This impacts on your x values, this impacts on your y. Multiply out. X dash equals. Now, I can show you again and again, or you just got to remember, if it's 0, this becomes 2x, because 0 times y is nothing, right? And when you start down here, 0 times x is nothing, this times that. So y dash is equal to 3y. Are we happy with that? Right? Top against the x, bottom against the y, write the sentence. Next step, once I've written that, what's that? What the hell is x dash y dash? I need to go back because my equation's got y's and x's in there. So I need to know what y is, what x is. Therefore, x is x dash over 2. Transposing, just got my x by itself. Y is y dash over 3. Yep. Okay. Got the box, went forwards, transposed. Same process all the time. From here, you go back to the guy that you were writing about and you replace. So where the y is, you put y dash over 3. Where the y was. Where the x is, under the root, you are going to put x dash over 2. Replacing. Yeah? That means y dash is 3 times root x dash over 2. That's my new equation. Once you've done that, you drop the sticks. You don't write the sticks anymore. You just write y equals. If I gave you this on a test paper, right, and said describe the transformations, what happened to this guy to get this? You would have said this 3 was a dilation from the x-axis. Yeah. True? And you would have looked in here, and remember, this is where it is. You would have said, hang on, x divided by 2, that's a half. Because the numbers are half, it's a dilation of 2, because you turn the numbers upside down when they connect to the x. Which is what it was in the question. So from here, you would have come back to this sentence. That's the thing that people find confusing about using the matrices versus normal transformations. Right? That makes sense for this sentence. We got there using matrices. You go, well, why the hell do I do that? Why can't I just write the transformations? Because they are studious matrices, and that's all there is to it. They say do matrices,